This is part 1 of lesson 10.9, representing functions by power series. In our last section, we introduced the idea of power series and we connected it to our Taylor polynomials. And we looked at some common functions that we could represent as power series. Now recall, the reason we want to do that is because looking at the behavior of a polynomial that represents a more complicated function is a lot easier than actually looking at the function itself. So in this section, we're going to start by using what we know about a geometric series. So we're going to look at functions that can be written in this form, a over 1 minus r, because if you remember when we started this unit that any geometric series of this form, n equals 0 to infinity, the sum of a times r to the n, converges to this sum, which is exactly how we're going to represent the power series in this section. And recall that a is the first term of the series and r is a common ratio. And also, the important part of this as well to help us is remember that if the absolute value of r is less than 1, then that geometric series converges. And that's going to help us with our interval of convergence. So let's start with this example. Find a power series for f of x equals 6 over x plus 2, centered at x equals 0. Give the first 4 non-zero terms and the general term, and find the interval of convergence. So we want to make it look more like our original idea that it is a over 1 minus r. So we have to turn this into that. So that's the first thing we're going to do. So we're going to start by taking 6 over x plus 2, and we're going to rewrite it a little bit. So first thing I'm going to do is I'm going to write it as 2 plus x, which is no big deal. And then I want to get rid of that 2 there. I want a 1 there. So I'm going to divide everything by 2. So I get 3 on the top, I get my 1, and then I have plus x over 2. Now that's closer, but remember I want this to be a over 1 minus r. So I have my 1. So in order to rewrite it as a minus, I just write it this way. I just put a negative in parentheses like that. So now we have a equals 3 and r equals negative x over 2. So now we can write this in the form that we want because it's in the form of a geometric series. So 6 over x plus 2 can be written as 3. Think of this how we write out a geometric series, which is the summation n equals 0 to infinity. I don't know why my pen is having problems here. Let's try that again. Of a times r to the n. So if we start writing out the terms, when n is 0, we'll just have a, so that's 3, and then we'll have minus, because we're putting negative x over 2 in. Give you guys this nice reference here. This is 3 times negative x over 2 to the n. So when I put 1 in for n, I'm going to have minus 3x over 2. And then when I put 2 in, I'm going to have the 3. And that minus is going to get squared. X is squared. And then the 2 gets squared. And then we're going to follow that pattern. So when 3 is put in there, and then the 2 gets cubed. Okay, like that. So we're going to have something like this. So we end up with 3 times negative x over 2 to the n. And so we can say that this converges when the absolute value of negative x over 2 is less than 1. And if we simplify that, we'll get negative 2 is less than x, which is less than 2. So there's our interval of convergence. So that's the basics of what we're going to be doing. So we can do this again by using long division and see how close we get. But I'll tell you, if you can figure out a way to write in the form of a over 1 minus r, you're much better off. So anyway, let's go through this so you can see how this can be a very tedious idea. So we're going to take 2 plus x, and we're going to divide it into 6. Okay, so the first term we can put up there is 3. So we're going to do 6 plus 3x. And then we'll subtract, and we get a negative 3x. And then that's going to go in negative 3 halves x times. So multiplying that out, we're going to get our negative 3x, and then the other term is going to be minus 3 halves x squared. And then we'll do it 2 more times here. So dividing, we have to subtract these, so they'll cancel, and we get a positive 3 halves x squared. And then dividing that into 2 again, we're going to get plus 3/4 x squared, and multiplying it out, so we'll get our 3 halves x squared, and then we'll have plus 3/4 x to the third. Subtracting these again, we get negative 3x to the third over 4. So I'll just put the next term up there so we have one more, which is going to be negative 3x to the third over 8. Okay, so if we compare these two, what we get is, let me just write this out here. So we have 3 minus 3 halves x plus 3x squared over 4 minus 3x to the third over 8, and it would continue. And if you notice that this can be simplified to 3 times negative x over 2 to the n, which is the same result we got before. So our power series representation for this function is spot on. But it's a lot easier than doing the long division as you would for a fraction and then figuring out how you can simplify it. So how do we go through this? So here are some ways that you can create power series. That was just one of them. Some of the other one is substitutions. You can multiply or divide the series by a constant or a variable. You can add or subtract 2 series, and by differentiating or integrating. And we're going to see one of those near the end, which is kind of cool. So let's go on to another example. So now we're going to find the geometric power series for f of x equals 4 over 2x minus 1, and this time it's centered at c equals 2, and we're defining the interval of convergence. So what we want to do is remember that, and I'm going to write this up here because we're going to use it a lot today, is our geometric series. So remember that 1 over 1 minus x can be written as the summation of n equals 0 to infinity of x to the n, and that's assuming, of course, that x, absolute value of x, is less than 1. So that's when a is 1. That's our most basic geometric series, and it's going to be like our best friend here. So if we take 4 over 2x minus 1, we want to put it in that form. So we want this centered at 2, so we have to change it a little bit. So that means we're going to take 4 over 2 times, and we're going to change this to x minus 2 And if we do that, we want to make sure that it still equals 2x minus 1. So we have to add a 3 here. So if you multiply the bottom out, you'll see that we have 2x minus 4 plus 3, which is going to give us our 2x minus 1. So we just have to show that it's centered at x minus 2. Okay, so just rearranging the terms a little bit so it looks like our geometric series. We have 4 over 3 times, 3 plus 2 times x minus 2. Now remember, we want that 1 there, so we're going to divide the 3 out. So this is going to equal, let me pull the 4 too, 4 thirds times 1 over, now we'll have 1 plus 2 thirds times x minus 2. So now we're in business. Now it looks a lot more like what we had before. So the only thing we're missing here is the negative sign. So this becomes 4 thirds, 1, we need that minus sign. So this will be negative 2 thirds times x minus 2. So now it's in the form we want it. So now we can write it as a geometric series. So in this geometric series we have a equals 1, and we have r equals negative 2 thirds times x minus 2. And also remember that we have that the absolute value of negative 2 thirds x minus 2 is less than 1. So because we're going to need that for our interval of convergence. So now we can write it in summation form. So we have our 4 thirds, and then we have our summation, n equals 0 to infinity. And then we have our r to the n. So that's going to be negative 2 thirds times x minus 2. This whole thing to the n power. So we can just clean that up a little bit so it looks a little bit like series that we are used to looking at. So we do have, with the negative sign there, we now created an alternating series, so we can pull that negative 1 out. That's for our negative in front of the 2 thirds. And then we have 2 to the n, and then we have x minus 2 to the n. And then in the denominator, we have 3 to the n. And the only thing I forgot was my intervals of summation. And there is our power series. Now, if you want, you can distribute the 4 thirds in and make that in the denominator 3n plus 1 if you want. And the only other thing we have to do is be a little more specific about our interval of convergence. And so if we multiply this out, we get negative 3 halves. Whoops, we're looking 3. Negative 3 halves is less than x minus 2, which is less than 3 halves. Okay, and if you want to clean that up a little more, like adding 2 to both sides, you get 1 half is less than x, which is less than 7 halves. So I'm going to stop here for the first part and pick up with the last 3 examples in the second video.